Okay, so section 14 is on the derivatives of trig functions. So we've already learned the derivative of sine and cosine. So the derivative of sine is going to be cosine, and the derivative of cosine is going to be negative sine. Okay? And I always say that you should make flashcards for AP Calculus, and nobody ever listens to me. But you're going to start having all these things that you have to memorize, and if you want to wait until the middle of the semester, and then you're like, oh, I should have been writing these this whole time, you're going to have like 200 different things that you have on the flashcards. Right? It's a test that you definitely need to memorize a lot of things. So I'm going to give you 6 things to memorize today. I know, 200, yeah.
Is that just like a made-up number?
Probably.
Oh.
There are a lot of things you need to know, though. Lots of theorems, lots of derivatives, and so on. So it says, find the equation of the tangent line to y equals 2 sine of x plus cosine of x at 0, 1. All right, so we know how to find the equation of a tangent line. All we do is we take the derivative. So when I take the derivative of 2 sine of x, I end up getting 2 cosine of x. And the derivative of cosine is going to be negative sine. Okay, now on your quiz, a lot of people set the derivative equal to 0. Okay, that's not what we're doing. That's what we do when we're finding the horizontal tangents. Okay, the locations of horizontal tangents. Okay, in this case, we're trying to find the slope, m. And we do that by plugging in our x value, which we were given, x is equal to 0. So we're going to plug in. So we have 2 cosine of 0 minus sine of 0. So cosine of 0 is going to be 1, and sine of 0 is 0, so we end up getting m equals 2. So then putting it all together, we have y minus y1 is 1, equals m, which is 2, times x minus x1, which is 0. So you can leave your answer like this, or you could recognize that 0, 1 is actually the y-intercept, right? So it's y equals 2x plus 1. You could do it that way as well. All right, so we're going to use the quotient rule to actually find these. So I told you guys I did this when I applied at a tutoring center, and I panicked because I'd forgotten all of my derivatives. That will not happen to you. You will know these. So if I have cotangent of x, I'm going to first rewrite it as cosine over sine. So I'm going to have y prime equals, and I do the quotient rule. So I do low d high. So the derivative of cosine is negative sine minus high cosine, d low, derivative of sine is cosine, all over the square of what's below. So we end up getting y prime equals, we have negative sine squared minus cosine squared. So what does that become? Negative 1, exactly. A lot of people on the quiz were trying to reduce out like here and here. You can't do that, right? You can't say like, if you had numbers, if you had 2 plus 5 over 2, you can't say that it's the same as 5, right? It's really 7 over 2. Does that make sense? So don't do that with the trig functions either. So we end up getting negative 1. Whoops, I erased part of it. We get negative 1 over sine squared x, which we end up writing as negative cosecant squared x. So the derivative of cotangent is negative cosecant squared x. Do you guys remember what the derivative of tangent was? Secant squared x. It's very close. Okay, so the cos are always very close to the regular ones. So cotangent is similar to tangent. Cosine has a derivative that's similar to sine, and cosecant will be similar to secant. All right, so let's find secant. So secant we know is going to be 1 over cosine. So when I do my quotient rule, y prime, I get low is cosine, d high, derivative of 1 is 0, minus high is 1, d low, derivative of cosine is negative sine. All over the square of what's below, so I do cosine squared x. So I get y prime equals sine squared, or sine of x, all over cosine squared x. And we end up breaking this apart. So we break up the cosine into cosine squared into cosine x times cosine x. Okay, so what I really have is sine of x over cosine, and then I still have a 1 over cosine. Okay, did you see how I did that? I just broke it apart into separate fractions. And then I think about what each of those are. So what's sine over cosine? Tangent. And what's 1 over cosine? Secant. So the way that we write the derivative of secant x is it starts out as itself, secant x, and then tangent x. So the 1 over cosine was the secant, the sine over cosine was the tangent. So secant x, tangent x. Yeah.
If I write it as tangent x over cosine, is it wrong?
It's not wrong, but it will be difficult to recognize it on the AP test. Okay, so if you recognize in these forms, it will help. Okay, so if I have y equals cosecant x, that's going to be 1 over sine. So when I take the derivative, I'm going to have low is sine, d high is 0, minus high, d low is going to be cosine, so it's very similar to the last one. All over the square of what's below, so sine squared x. So I get y prime is negative cosine of x all over sine squared x. So imagine breaking it into the different pieces. So I'm going to have the negative cosine over sine. Oh, I ran out of room. Let me put it on the bottom. I'm going to have negative cosine x over sine of x. Cannot write today. Sine of x. And then times 1 over sine of x. So let's start with the 1 over sine. So what is 1 over sine? Cosecant. So we're going to have a cosecant x. And what's the cosine over sine? Cotangent. What else do we have? Negative. So it's negative cosecant x cotangent x.
Does it matter which one you put first?
It doesn't, but the form that you'll see in all the textbooks will say cosecant x cotangent x. Yeah, so I always remember that the secant and cosecant start as themselves. Okay. All right, so there is a pattern, and a lot of these will go together, right? They're very similar to each other. So when you see sine of x, we know its derivative is cosine, and we know cosine its derivative is negative sine. I think you guys have those down. All right, those ones go together. All right, tangent, its derivative is secant squared, and cotangent is negative cosecant squared. So we gained a negative and a co. All right, and then cosecant x, its derivative, well, let's do secant x first. Secant x, its derivative is secant x tangent x. And cosecant, again, gains the negatives and the cos. So it's going to be negative cosecant x cotangent x. Does that make sense? They go together. So if you can memorize secant, tangent, and then the sine and the cosine, then I think you're good, because you can get the cotangent and cosecant from their cos. Does that make sense? All right, so it says, whenever I forget one of these derivatives, I just use the quotient rule and find the derivatives of sine and with the sine of derivatives of sine and cosine. However, it's best to memorize all of these. Why waste time? So you're already crunched for time in the long, it's a huge, very, very long test. And you're crunched for time, you really are. Like, people will run out of time on the AP test. So why waste time when you can just know those? Okay, so then we have things like find the 30th derivative of the sine function. Do we have all day? It's going to take a bit, isn't it? Think there's a pattern? We'll see. We're just going to do it. All right, so I have y equals sine of x. The first derivative is cosine. The second derivative is negative sine then. The third derivative, we call that triple prime. The third derivative is negative cosine. And the fourth derivative, we get lazy. We don't like to write the 4 because it gets a little crazy if I had 30th derivative and I had to do that would be crazy, right? So once we get to 4, we do a parenthesis with a 4. So the fourth derivative, like that. And what's that going to be? Sine, yes. So I'm going to move that. I'm going to move it. Maybe. Oh, I can only move part of it at a time. Great. We'll move part of it. I was too slow in writing it. It doesn't recognize it as one thing. All right. So what about the fifth derivative? What's it going to be? Cosine. Sixth derivative? Negative sine. Do you see the pattern? Seventh derivative? Negative cosine. So then the eighth derivative, right, is again sine. So then what's the next one going to be? The 12th, and then the 16th, and so on. So it's every multiple of 4. Do you guys see it? Every multiple of 4. So we're going to have y to the, not really to the 28th. The 28th derivative is going to also be sine. Do you see it? So then what's the 30th? Yeah, because you're going to have 29 goes to cosine, and then 30th goes to negative sine. Does that make sense? So there's a pattern. So for sine and cosine, it's always going to be every 4. There are not patterns for secant and so on. Like, those ones are very messy. You'd have to do product rule a lot. All right, so number 2, so differentiate. So we have f of x equals cosine x over 2 plus sine of x. So when I see this and I notice that it's a quotient, I have to do my quotient rule. So I'm going to do low d high, derivative of sine is negative, or derivative of cosine is negative sine, minus high d low. So what's the derivative of 2 plus sine of x? Just cosine, right? There's no 2. A lot of people will leave the 2 there. Derivative of 2 is 0. And then we have 2 plus sine of x squared. So now we're asking, where does it have a horizontal tangent? That's when we're trying to find when our slope is equal to 0. Okay? So we're going to continue to simplify. So I'm going to distribute my negative sine in. So I get negative 2 sine of x minus sine squared x minus cosine squared x all over 2 plus sine x quantity squared. So what do we see? Right here, what's this to come? Yep, minus 1. Yep, so we're going to have negative 2 sine of x minus 1 all over our denominator. Now, when I set this whole thing equal to 0, I have a fraction that equals 0. The only way a fraction is ever going to equal 0 is if the numerator is equal to 0. Okay? So it doesn't matter really what's happening with the denominator. You can almost think of this denominator as going over and just like canceling. We don't really do that, but it doesn't really matter as long as there wasn't like a hole or something like that. So we're good. So we're going to have this piece equal to 0. So I'm going to say negative 2 sine of x minus 1 is equal to 0. So I'm going to add the 1 over. I'm going to divide by negative 2. So I get sine of x equals negative 1/2. Now, it would have been nice if I had said on the interval 0 to 2 pi, but I didn't. Okay, so we actually have to include all solutions. All right, but it was nice that I said for what values of x. I didn't say what points. Do you remember points? You always have to find the y value. So I didn't say that. That's good. Okay, so let's think about it. The other class had trouble with this. Are you guys pros at this? Do I need to give you a surprise unit circle quiz at some point? Okay. Where is sine equal to negative 1/2? 7 pi over 6 and 11 pi over 6. Good. So I get 7 pi over 6 and 11 pi over 6. Okay, but there's other answers. I didn't say just on the interval 0 to 2 pi. So I could continue to add 2 pi to 7 pi over 6 and 2 pi, or I could subtract 2 pi, right? So the way we write our answers is we say 7 pi over 6 plus 2 pi k, and then we say 11 pi over 6 plus 2 pi k. There's no way to like shortcut it and put them together into one. It's not like the tangent ones where it's every pi, right? So we have to just do that. Does that make sense? My 7 and my pi ran in together. 7 pi over 6. All right, number 3. So find the equation of the tangent line to the curve f of x equals x times secant x at the point pi over 3 and 2 pi over 3. All right, so we're going to go ahead and find the slope. And we have x times secant x. So do you see that you need the product rule? Right, we can't take the derivative of each one. We have to do the product rule. A lot of you guys try that on your quiz. You just try to take derivative of one thing, derivative of the next thing, right? And just multiply them together. Like you have to do derivative of one, second one normal, plus derivative of the other one, second one normal, first one normal. So we're going to have derivative of x is 1 times secant x. Derivative of secant x, well, I'll do x as normal, and then derivative of secant x is secant x tangent x. And you could clean it up a little bit, like you could pull out the secant x, but at this point, I would just plug in. So basically, we want to know the slope at pi over 3. So I'm going to plug in pi over 3. So I'm going to have 1 times secant of pi over 3 plus pi over 3 times secant of pi over 3 times tangent of pi over 3. Lovely. This is a very nice slope. All right, so secant of pi over 3. So let's think about where pi over 3 is. It's right here. That's the point 1/2 comma root 3 over 2. The secant is going to be 1 over the cosine, right? So what's 1 divided by 1/2? 2. So secant of pi over 3 is 2. Then we have plus. We still have pi over 3 out front. Secant of pi over 3 we said was 2. How about tangent of pi over 3? Tangent of pi over 3 is going to be the y value divided by the x value. What's that become? I heard someone say it. Ben, did you say it?
Jeez.
Root 3. Jamie, I can never tell like when you're talking. It's like you throw your voice around the room. You're just a ventriloquist. That's what I've decided. So we get root 3, yeah. So that's a very strange answer. So it's going to be 2 plus 2 root 3 all over 3, and I'll put the pi kind of on the side like that. Lovely. So that's when on the AP test, if I'm like, oh, I don't like that number, I don't want to use that number, I just round to 3 decimals, right? You can always do that. So you could find that answer to 3 decimals. But in this case, it just says find the equation of the tangent line, and it gave you the point. So I'm going to say y minus 2 pi over 3 equals m, so 2 plus 2 root 3 all over 3 pi, and then times x minus pi over 3. So it's gross, but that's the answer. We'll leave it like that. Get it? All right, one last question. All right, so this one says an elastic band is hung on a hook. So let's say we have this little hook there, and we have a like stretchy band from it, and we have some kind of mass. Okay, and if you pull that mass, it's kind of like a spring problem. You pull the mass, and then it's going to vibrate. It's going to go up and down, up and down, up and down. Have you seen these before? So whenever we have these types of problems, this is called simple harmonic motion. So basically, if I graphed it, and so I know it just goes up and down, up and down, up and down. But if I did it with respect to time, it would look like this. Like it would be like a wave. Okay, so that's going to be like some kind of sine or cosine function. Simple harmonic motion. So it says the equation of motion is given by this. So this is our position. For t is greater than or equal to 0, we can't have negative time. And s is measured in centimeters and t is in seconds. So it's definitely telling you s is our position. It's in centimeters. It's a distance, right? A length. So use your calculator to help you answer the following questions. So first we're going to find the velocity. So if we have the velocity, it's just going to be the derivative of s, so s prime. So the derivative of negative 2 sine of t plus 5 is going to be negative 2 cosine of t. And then your acceleration is going to be s double prime. So it's going to be negative 2 times negative sine of t. So I'm going to get positive 2 sine of t. All right, now the question says, when is the speed the greatest? Okay, so what do you think that we can do? You could do several different things. What could we graph? Huh? Set what equal to 0, though? It's actually acceleration. It is acceleration. Because you would want to find the max or min, right? Because speed can be positive or negative. So you'd actually want to find, like, if you graph the velocity function. So don't draw this out. I'm trusting. This is not very precise at all. But if I graph the velocity function, it actually goes above and below, actually. And I want to find the speed. Right, the speed is just going to be the absolute value of these numbers. So if I got like a height of 3 here and a height of negative 3 here, then the speed for both of those is actually 3. Does that make sense? So you would want to find maxes and mins, and that happens when the horizontal tangent is equal to 0, right? So what you're doing is you're taking your velocity function and you're finding when its derivative is equal to 0, okay? So if this is calculator active, what else could we do? You could graph. You're using very vague terms. AP test doesn't like that. Graph what? You said graph it. Graph the velocity and just find the maximums and minimums, right? So let's try it. So I'll go ahead and do it on this one. So get your calculator out. In AP Calc, your calculator should always be set so that we have it in radians. I'm going to deselect this. I was showing the other class that's still up here. So let's say I graph negative 2 cosine of t. Is that the velocity? Or cosine of x, I guess. And I want to make sure that I'm set in radians. So my mode is radians. My window, I just had it start at 0 since time can't be negative. So it started at 0. And I just went 0 to 10 and then negative 10 to 10. And then I hit graph. Okay, so this is what the velocity function looks like. And I think you guys should kind of know what that's going to look like. If you have negative 2 times cosine of t, could you do that without a calculator? Probably. You might need to do a little t-table or something to figure out a few points, but you should know what that means. It means that instead of going up to a height of 1 and negative 1, right, it's going up to a height of 2 and negative 2. And it's starting upside down. It's starting at the bottom at negative 2 comma 0 and going up. Right? Does that make sense? You guys remember all that? Pre-calc? Oh, pre-calc. All right, so we're going to do second trace. And we're going to find the, let's find the maximum. So 4. So I'm going to go over here. I'm going to find this. Left bound, right bound, guess. And when I do this, my calculator tells me that my answer is 3.1415935. And this bothers me because I have memorized lots of digits of pi. Have you guys memorized lots of digits of pi? And it's wrong, right? Should it be at pi? It should totally be at pi. So your calculator has rounding error, and that happens. So it should actually be at pi because we know that the cosine of pi is negative 1. So that's why it's at a height of 2 there. Okay? Now if you find this minimum over here, so if I do second trace minimum, so go ahead and do that along with me. Where do we think that's going to be? Yeah, it's at 2 pi. So 2 pi comma negative 2. So the speed in both of those locations is actually 2. The speed is the absolute value of the velocity. So your speed is 2 in both those locations. So it's happening at every multiple of pi. Okay, so you could write pi k for your answer. Does that make sense? Now, if you wanted to get super fancy and you didn't want to try to find everything, if you just wanted to compare those maximums and minimums on one graph and there had been some kind of shift or something, what I would do is I would put it in not like the way that I did on Y1, but the way I did on Y2. So do you guys know how to find the absolute value on your calculator? So you do math, you go over to number, and it's the first thing. It's absolute value. So I put mine in as absolute value. Why would I do that? Why do I do absolute values around it? Because it's the speed. So I actually graph the speed. So when I graph that, what happens is everything that was below the axis now gets popped up to the top. Make sense? And then you can compare those different heights. Does that make sense? You get it? So there's lots of things you can do on the calculator, lots of different ways you can answer the question. All right, so the speed is the greatest at every multiple of pi. Okay, that's our answer. Make sense? If it asked for the speed would be 2 centimeters per second.